is a little dicey. I'll give you that. Okay, but when you don't bring your writing utensils, you know.
My sister took it.
Your sister took it from you. Is your sister older or younger than you?
She's a little bit younger.
You're blaming your younger sister? Come on. Stop going blurry. Figure yourself out. Okay, questions, comments, concerns on any of these? Would anyone like me to do them? Any one of them? Yes. Number 1. Like, really, this guy here? 2. Did we do your homework? Did you do your homework? You had 20 minutes of class and you did nothing.
I did it, but like, I did it wrong.
Okay, you fixed it after. So number 2. You want to do number 2? Here's number 2. So we want to group our like terms. So if you recall, like terms have the same variables, and those variables have to have the same exponents. So, there we go. I'm just going to start left to right looking for like terms. So I've got a -4 here. No variables. Are there any other terms with no variables? Yeah, that guy there. So I'm going to use the sign out front. I've got a -4 and a +3. -4 plus 3 is? -1. And now we're going to keep going. I've got, the next one is and I have to use the sign out front, a -y². Are there any other y² terms? You bet. There's one right here. And so now, and these are they're like because they both have y's, their y's are both squared, and there's nothing else there. So now we look at the coefficients. The coefficient here is, Gershon? No, don't listen to Dilkaran. -1, because that minus sign has to be part of it. It's -1. And this is 3. So it's -1 plus 3. It is 2. It is +2. So we're going to go plus 2y². And now we're going to write these in the correct order of biggest degree on down. It's going to be 2y² minus 1, and you're done. Oliver, good morning. Who would you like to partner with for the zombie apocalypse? Okay. You are the second person who's willing to sacrifice Hayden to the zombies. Hayden, I think you need new friends. They just want to toss you to the horde. Okay. Gershon, does that make sense? Okay. You didn't flip it? You wrote it like this? I would still give it to you. You didn't get it wrong. Okay, guys. Oh, it's important to recognize this. This 2y² minus 1 and -1 plus 2y² are the same thing. This is the argument I was trying to have with Gershon D yesterday. On both of these, I've got a -1 here and I've got a -1 here. I've got a plus 2y², and if there is no sign in front of the coefficient, it's assumed to be positive. So this is also a plus 2y². These two are equivalent. If you wrote this and I wrote this, you're good. This is best practice. This is convention. But if you wrote me this on a test or a quiz for this stuff, I would not mark it wrong. Okay? Is there anything else anyone would like me to go over from this page? Number 8. Okay, let's look at number 8. So I've got 4n² plus n minus 2 plus n² minus n² plus 7 minus 5n. So I'm just going to start at the left and look for like terms. I've got an n² there, 4n². Hayden, are there any other n²? You asked about this one, yes? Okay, so I've got my 4n². Are there any like terms with this guy? You need to look at the question. You have to have, so Hayden, you have to have the same variable with the same exponents. So look at the list. Are there any other n to the power of 2's? How many? There's 2 of them. One right there and one right there. So these guys are going to be like terms. You say, I don't know, too quickly. So I've got 4n². When there is no number written, just a plus sign, the coefficient is a 1. Yes, Gabe, thank you. If it's just a minus sign, it's -1. So I've got 4n squared plus 1n squared, which is how many n squareds? Yes, Marcus, it's 5. Minus 1. Back down to 4. So there's my 4n squared. Now, let's look at my n's. I've got a plus n right there. Do I have any other like terms with that n, Hayden? The negative 5n. You include the minus sign up front. So 1n minus 5n is negative 4n. Negatives are important. And then I've got a negative 2 and a positive 7 is plus 5. And we're done. Yeah, it's totally doable. Jackson, do you have a ready utensil? Did you find it? So why would you say maybe? Ah, I see. Okay. How do we feel about collecting like terms? Are we okay with collecting like terms? It's not supposed to be super challenging. I gave you guys a bunch of practice, additional practice with this guy yesterday. Another 21 questions of this stuff. How does a Hawaiian baritone laugh? Aloha. Yeah, because you Googled it, because I told you you could. Why you would just, I mean, you can Google it to check it, but again, that's a classic example of doing the shortcut of work, not actually learning anything. And when I give you a test or a quiz, you're going to get annihilated on it. So, I mean, I told you you could Google it to check it, but you don't actually learn anything when you do that, and I don't take these things in for marks. So it's really not a wise idea. Yeah, to check it. The two of you are not the ones who should be taking shortcuts. Okay, so that is the pun, aloha. Are there any of these anyone would like me to do? There was 21 additional questions here for you guys to practice with. Okay, hearing nothing, let us continue. Find me this page, adding polynomials. See how this one goes. I need to open up this, and I need to open up this, and then I need to open up this. There we go. Let's see how much we get through today. Adding and subtracting. Okay, so adding polynomials. We're going to start combining these things. Yesterday we were adding like or combining like terms, simplifying expressions. Adding polynomials is more of the same. It is identical in almost every respect. When you're adding polynomials, it looks something like this. I've got a trinomial here. I've got x squared plus 2x minus 1. In brackets, that signifies that this is one big mathematical object. And to it, I'm going to add this whole thing. Now, adding is really quite straightforward. Subtracting is where things get a little bit more dicey, but adding is really straightforward. All we need to do is, if there's nothing else out front here, we'll recognize that I've got this, and I'm adding to it this. All we need to do, again, because there's nothing out front here, we're looking at multiplying in a couple days. There's nothing right here. We're just going to drop the brackets and gather the terms, Hayden. Hayden. Stop talking to Oliver. So we're going to group these things. I got x squared plus 2x minus 1 plus negative x plus 2. The first step is to just drop those things. Drop the brackets. And now I'm just going to gather our like terms. Are there any, I'm going to start from the left and I'm going to work my way right. Are there any terms that are like x squared? Again, to be like, you have to have the same variables with the same exponents. So there are no other x squareds. So that's great. This is just going to equal x squared. That guy's done. Now, plus 2x. Are there any terms that are like plus 2x. Yes, Juno. Yeah, the negative x. So I've got a plus 2x and I've got a negative x. I'm adding the negative x, so I really should include that sign out front there too. I've got plus a minus x. So 2x plus minus x is the x's don't change. We just adding and subtracting coefficients. 2x plus negative x. 1x. And it's a positive 1x. So we're going to go plus, and now I'll put in the 1, but I'm going to change that in a sec here because we don't actually need to write the 1. If there's only 1, we just write it as x. And now I've got a negative 1 there. Are there any terms that are like negative 1? Yeah, the plus 2. So we'll circle these two up, and then I'll group them. Negative 1 plus 2 is? Positive 1, yeah. Oh, plus 1. And now, just to clean this thing up, x squared plus x plus 1. If you left it like this, at this stage, grade 9, I would totally give it to you. But it is best practice to clean these things up and make sure it's written in the right order. But this would be totally acceptable on test or quiz. Questions about what I've done there? Like adding is super straightforward. I hope. Let's do one more. I've got this guy here, 2x squared plus x plus 5 plus 3x squared minus 2x plus 5. So first step, we're just going to, because there's nothing else going on here or here, we're just going to drop these brackets and group our like terms. 2x squared plus x plus 5 plus 3x squared minus 2x plus 5. Drop the brackets, rewrite the question. This is how I want you to show me your work. And now we're going to group our like terms. Are there any terms like 2x squared? Yes, Hayden, thank you. Be positive 3x squared. So 2x squared plus 3x squared is? You bet. Next term. Are there any terms like this plus x? It's not 2x, it's negative 2x. Okay, so I got that guy there and that guy there. You have to make sure you include the sign out front. So if I have plus x minus 2x, how many x's do I have? I have negative 1x. And now I've got a plus 5 here. Are there any other like terms with the plus 5? Yeah, another plus 5. So I'm going to put a triangle around those guys. Add my triangles together. Plus 5 is? Plus 10, and we're done. Cleaning it up, it would look like this. 5x squared minus x plus 10. But again, either of these is acceptable. And that's it. It's just like the stuff that we did yesterday with a little bit of an extra first step. So here's what I'm going to get you to do. Flip the page. We'll look at subtraction in, what time is it, 8:30? I am going to give you, I don't know, sometime. Class ends at 9:30. Now we'll see where we're at in 20 minutes. I would like you to do this page. I would like you to do all of this page. And in 20 minutes, we're moving on to the next part of this lesson. I will walk around and help where needed. On your mark, say giver. Pause the video. What I want to then make sure we do is subtract the like terms in this one from their like terms in this one. So I've got negative x squared, and we're going to subtract. Now the like term for this one in here is this negative 3x squared. So I've got negative x squared minus negative 3x squared. How do I subtract negative 3x squared from negative x squared? This minus this, that double negative there, is going to turn it into addition. So using this method, there's a lot more that's going on inside your head. If I've got negative x squared plus 3x squared, what am I going to get? Positive 2x squared. that guy's done, and that guy's done. I got a negative 2x minus a negative 2x. So if I'm at negative and I'm subtracting a negative, like you said before, is the same as addition. So negative 2x plus 2x effectively is, it's going to be 4, it's going to be 0. Which one? Negative 2 plus 2 is? 0. So if it's 0, I don't have to, if it's everything is ever 0, don't write 0x, it's just gone. It's gone, it's gone. And I've got negative 3 minus negative 1. Subtracting a negative is the same thing as adding. Negative 3 plus 1 then is going to be negative 2. So there's a lot more that goes on inside your head here. Not for a book that big. I don't have a stapler that'll do that. Ask him. Sorry, man. So that's one way to deal with this. Again, a lot more going on inside your head. This way is almost certainly going to be quicker. Let's write it out again. Negative 2x squared minus 2x minus 3 minus negative 3x squared minus 2x minus 1. There's the question. It's the same one we just did. And rather than thinking it through piece by piece, I'm just going to make sure that this negative out front of the bracket gets applied to each term inside the bracket. The first bracket doesn't change. It's going to be negative x squared minus 2x minus 3. And now I'm going to apply this negative onto each one of these pieces and drop the brackets. So then subtracting negative 3x is the same thing as adding 3x squared, that double negative there. I'm going to apply that negative to that negative, and I'm going to get adding again. I'm going to apply that negative to that negative, and I'm going to get plus 1 again. And now I'm just going to group our like terms. Negative 3x squared, sorry, negative x squared plus 3x squared, 2x squared. I've got a negative 2x plus 2x, 0. Those are gone. And I've got negative 3 plus 1 is negative 2. This way requires more writing, but you are less likely to screw it up. This way, thinking about it piece by piece, I think actually makes more sense with how you're subtracting, but it's less written on the paper, more to keep track of in your head, and you're more likely to screw this one up. Jackson, wake up. Okay? So at this stage, I would recommend you do this, but I want to model this just because it's how we're thinking about it. And that's it. We've got adding and subtracting. Questions? Do we see the difference? Okay, if there's no questions, I will free you to work. What I'd like you to do, it gets more interesting. Yeah, let's do this way. So the instructions here just say simplify the following polynomials. So whether you're adding or subtracting, whatever it says is now what you're going to do. I want you to do this page odds. Well, and the next page odds. So it's 1 to 19 effectively. There's a couple at the bottom. 17 and 19 are going to be interesting. Those are fun ones. And then I want you to flip the page. There's a couple more I want you to get through here too. I want you to go over here and I want you to look at question number 10. A, and I want you to do all 4 of those shapes. Just keep flipping, Hayden. You'll find it. Okay, so I want you to do 10 on this page. I want you to flip the page again. I would like you to do question 12. I'd like you to flip the page again. I would like you to, on this page, I want you to do questions 10 and 12. 10 and 12. Some more practice doing the check the work questions. I'd like you to do 13A and B. And we'll call that good. Okay, so there's a bunch in there, but you got almost half an hour, 25 minutes, something like that. That's what I'd like you to take a look at now on your market set giver. Jackson, if you're gonna be here, man, you gotta be awake. Okay, on your market set, go.